Okay, so this is lesson 7 of Python for data analysis. We're going to start, as usual, by going to the GitHub page for the course. Here, I can go down, you can click on lessons, and we're going to go to lesson 7, and then click on this raw link. That'll take us to the JSON file. So we're going to copy that link, and then go to our lessons folder, which I've already opened up here, and I've activated the Python 3 environment as well. I'm going to do curl-O quotes that link, paste that link in there, put another quote, download it. Okay, and then I'm going to type Jupyter Notebook, and so we just downloaded this lesson 7 a few seconds ago, so open that up, and there we go. Alright, so again, there's the readings are listed here that were done, supposed to be done for today, and then the table of contents as well. Everybody able to get this far? Okay, so today we're going to continue covering data types in Python, and there's several listed here. So the main things we're going to cover are logic, which includes a Boolean data type. We're going to cover loops, which use those Boolean data types, and I'll tell you what that means in a minute. Lists, tuples, and dictionaries, and a couple other data types as well. So I've listed here dictionaries, tuples, lists. Can anybody name like some data types that we've already covered in the class? Strings. Okay, there's one. I can think of at least 2 others. Integers. Yeah, floats. Yeah, floating point values as well. Those are the 3 that come to mind, but I'm sure there's some others too that we touched on. In fact, when we did the crash course that you did on your own, you would have covered most of these that we're going to cover today. So these are different types of data, or object types. Another name for them is classes. So these are types of data that you have when you have a data type or an object in Python. There's the class, which is like the kind or the type of object that it is, and then there's the object itself, which is an instance of that class. So you have this type token distinction. So the type is this general description of that object type, and then the token or the instance is an actual thing. So you have we have laptops in this room, right? Laptop is a class of object, right? It's a kind of thing. But each of us has our own laptop. That's the instance of a laptop. It has its own uniqueness and its own properties, but it also inherits properties of a laptop, right? It is a computer. It opens up. It has keys. It needs to be charged. It has all these properties. So in Python, because Python is this object-oriented programming language, you have object types, and then you have the instances or the tokens. In computer science, we call them instances. In philosophy, we call them tokens, but it's the same idea. You have a category, and then you have individual instances of that thing. And so as we go through this, we want to be thinking about what kind of type of object are we dealing with. Is it a dictionary? Is it a list? Is it a string? Because depending on what type of object, it will have certain properties that that we can use and pull out information and do things with it based on what kind of object it is. Okay, so that's like a little aside about object-oriented programming. We'll kind of come back to this again. So the first thing I wanted to cover today, and by the way, these are all links, so you could, if you want, you can click on this and it'll take you down to that first box here. Okay, so the first thing we wanted to cover is logic. And so this gets into a little bit of like mathematics and philosophy and stuff, but we're not going to get too deep. But generally, a statement can either be a statement that has truth value can be either true or false, and we use this in a programming context to control the structure or control the flow through our program. So in Python, these logical statements have a special data type called bool, and this is named after Boolean logic or Boolean algebra and the founder George Boole. So there's, in addition to having a statement that can either be true or false, we also have operators. So we have and, or not. So this is, for example, if we do x or y, what that means is if either of x or y is true, then the statement will be true. Another way of saying that is if x is false, then y, otherwise x. That's sort of a more like logical formalism, but basically x or y is if either x or y is true, the statement is true. X and y means both x and y must be true for that statement to be true. And then not x is just the opposite of x. So if x is true, then not x is false, and vice versa. We'll see these in some real-world examples in a minute. Another thing we have is comparisons, and you should be familiar with these from math, right? You have less than or equal to, greater than or equal to, is equal to. That's two equal signs. That's a comparison, not an assignment. Remember, an assignment is just a single equal sign when we store something as something else. Not equal is an exclamation mark followed by an equal sign. And then we have these two related things called is and is not. So these are similar, but not the same as this equal comparison and not equal. The difference is that the equal and not equal are evaluating the values of expressions, and the is and is not are actually saying, are these the same thing or not? Are these the same object? And I'll explain that in a minute. So some examples here. So okay, let me first of all, I need to let's clear the output so we don't give anything away here. So we're going to go down to cell, all output, and clear. And then now we can start executing stuff. So I would normally put this 1 + 1 in parentheses, but it's technically not required because of the way Python does order of operations. So if I can execute that, this is going to say is 2 equal to 1 + 1, and the answer is true. So that also works with strings. So we can do A plus B, which remember is concatenating or combining A plus B as a single string. We can see, is that true? And the answer is yes. We can also do is, are these two expressions both true? So this first one we put in parentheses and the second one, yes. And then we can also do an or statement. So we can say, is 5 greater than 4 or is 2 less than 1? So we know that 5 is greater than 4. That should be true, but 2 should not be less than 1. So basically this is saying true or false. And so since this is an or statement, it evaluates as true. Now this next one gets into this difference between this equals operator and this is operator. So we can say, is the integer 5 equal to the floating point value 5.0? And that's true. But if we say 5 is 5.0, it's going to say it's false, because these aren't the same object. If we said 5 is 5, it would say true, or false is false, it would say true, because those are the exact same object. When Python, even if you have two different variables that are named differently, but they represent the same, they point to the same object, like say 5, the integer 5, if you say, are those two things equal, it will say yes. And I wonder if I have a, so for example, if I do so what it's doing is it's saying, is A and B the same thing? Yes, because they both are 5. And so it also works for strings, and also this not equals, it also works for strings. And these expressions, true or false, these are type bool, and we'll come back to this type function at the end. But this is a way that you can figure out what kind of type you're working with. Okay. So far, so good? Okay, so I wanted to cover a few little asides here that are come in handy. One is ranges, and the other is increments. We've kind of touched on these already, but I want to give a little more formal treatment. So one is this operator called range. So this just generates a range object that goes from 0 to 5. If we actually want to see what's in that range, we can type list, and then in parentheses range 5, and it will pull out that list. So what this gives us is a range of integers from 0 up to the number that we give, but not including that number. So the list itself will actually have five elements. If we wanted to actually get from 1 to 5 exactly, we could do range 1, 6, which is a special version of that, which starts at 1 and then goes up to 6. But again, not including 6. This is that sort of fence post behavior of Python that we talked about before. When we start using NumPy, there's a NumPy function called arange that is like range, but it's a little more sophisticated. So in programming, you often want to increment an integer. So you want to, or you have a variable that is storing an integer, and you want to increment by 1. Sometimes you won't have like a little counter that's counting like every time you go through a loop, and you're going to add 1 every time or something like that. So oftentimes you want to increment. There are operators that are shortcuts for this. So the one that Python supports is this plus equals. So if I have I stored as 1, and then I add 1 to it, I could do I equals I plus 1, and then I will be 2. However, a shorter way to do that is to use this notation I plus equals 1. That's exact same as doing this, but it's just a shorthand. You don't have to rewrite I every time, and that gives you the same thing. This also works with multiplication, so you can do j equals j times 3, or j star equal 3, and it will give you the same behavior. So this is just a little shortcut. In other programming languages, you might have seen up this like plus plus operator. You can do I plus plus. This doesn't work in Python, so you have to use the plus equals notation. And we'll see how those might be useful later.